Hi, I am Dr. Shyam Sarkar. Welcome to my class. Don't forget to subscribe this channel for more updates. Today I will discuss 20 question answer from Aromaticity. If you want to know the details about aromatic, anti-aromatic, non-aromatic compounds and what is aromaticity, which one should be aromatic, anti-aromatic, non-aromatic, and why they are this type of category. Okay, so if you want to know all these details, you must watch my previous videos on aromaticity. So in lecture 1 I have discussed all the basic concept about aromatic, anti-aromatic, non-aromatic, Hückel's rule, and if you watch this lecture within few seconds you will be able to answer all the question answer related to this in competitive exam. And in the second lecture you will find why benzyne is aromatic in details with orbital picture diagram, and there are 2 MCQ related with the benzyne molecule. So both the links I have shared in this video description. You can find it easily and go through this lecture, because in exam one question is very common from this aromaticity. So you just go through this link and watch those video to improve yourself. Okay, now let's come to this question answer discussion session. So first question, we start with very simple example. So this is sample question. See here, which of the following species is aromatic? So 4 species are given. So as I showed in the earlier video, so similar chart I will show for the 4 molecules. So this data sheet, that means 4 conditions should be fulfilled, then only we can say which category of these compounds are either aromatic or anti-aromatic or non-aromatic. So let's go one by one with the first one. So this is cyclobutadiene. So cyclobutadiene is cyclic and this is conjugated, this is planar, and it fulfills the 4n pi electron rules where n equal to 1. Okay, so this is anti-aromatic type of compound. Next molecule you can see here, this is cyclic, so cyclooctatetraene. So this is cyclic, but this is not conjugated because these exist in different form, that is it exists in the tub shape or tub form, or you can say boat form. Okay, so this does not exist in the planar form. So this is not planar, this is not conjugated, although it has the 4n pi electrons where n equal to 2. That's why this compound is non-aromatic in nature. Okay, next molecule, if you see, this molecule has one sp3 carbon atom. So this is not conjugated, so this is not planar, and although it possesses 4n plus 2 pi electrons where n equal to 0, but this is not aromatic, this is not anti-aromatic, this is non-aromatic. If you see the last molecule, so this has one positive charge, so this is cyclic and this is conjugated because that positive charge, that means that carbon is sp2 hybridized. So this is fully conjugated cation and this is planar, and it obeys Hückel's rule, that is 4n plus 2 pi electron rules, that means here n equal to 0. Okay, so this is aromatic. So we got our answer. So in question they asked which one is aromatic. So option D is the correct answer. In this way you have to solve all these problem. Okay, next question we can see here. So similarly 4 options are given. We will go with the similar chart, because if you follow the same chart always, so it will be easier for you. Okay, so we will go one by one molecule. So first molecule, if you see, this is cyclic, this is conjugated, and this is planar, and this obeys 4n pi electron rules where n equal to, if you see, n equal to 2, that means 8 pi electrons it has, because nitrogen is having one lone pair and 3 pi bonds, so total 8 electrons means n equal to 2, and it's obeying 4n pi electrons rule. So this is anti-aromatic in nature. If you see the second one, so this one is cyclic, but this is not conjugated and this is not planar because one sp3 carbon atom is there, so this is not planar. It obeys 4n plus 2 pi electron rule because it has 3 pi bonds. So if you put the value of n equal to 1, so it has 6 pi electrons, but this is non-aromatic in nature. Next one, this is cyclic. This is conjugated, because if you see this this is 8 electrons. Okay, so it has 8 electrons, that means it has 4n pi electrons rule, it obeying 4n plus 2 where n equal to 2, and this is becoming anti-aromatic. So this is anti-aromatic molecule, it has 8 pi electrons. Okay, so next one, if you see, so this one is having boron atom in the heterocycle. Okay, and boron, we know that it has vacant p orbital. So these conjugated bonds can be conjugated with the p orbital of boron atoms. So this is cyclic, and this is fully conjugated, this is planar, and 4n plus 2 pi electron rules, and this that means this is obeying Hückel's rule, that is 4n plus 2 pi electron rules, because it has 3 pi bonds, that means 6. If you put the value of n equal to 1 here, so 4n plus 2, that means 6 pi electrons. So this is aromatic. Now if you see the answer, so option D, that means D is the correct answer. These will exhibit aromaticity. Okay, so we got our answer, option D. So next question, if you see, among the following compounds that will exhibit aromaticity. So aromaticity will exhibited by, let us see which of the following molecules or following compounds. Here multiple answer it may be, because this is MCQ type question. So let us see one by one. So first one, if you see, this is cyclic, this is conjugated, and this is planar, and this is obeying 4n plus 2 pi electron rules, because 3 pi bonds, that means 6 pi electrons, n equal to 1, that means 4n plus 2, 6. So this is aromatic in nature. And if you see the next one, this is also cyclic, this is conjugated, this is planar, and 4n plus 2 pi electron rules, that means it's not obeying, this is obeying 4n pi electron rules where n equal to 2. So this is anti-aromatic in nature. And if you see the third compound, so this is cyclic, this is conjugated, and this is planar, this is obeying 4n plus 2 pi electron rules where n equal to 1. So this is aromatic in nature. Okay, let us see the next one. This is cyclic, this is conjugated, planar, because all the carbon atoms are sp2 hybridized, and these two double bonds can be conjugated with this carbocation p orbital. So this is obeying 4n pi electron rules, and this suggesting the compound should be anti-aromatic in nature. Okay, so we got here two aromatic character, that means compound P and compound R. So P and R are the aromatic in nature. So if you see, it's matching with option C. So option C is the correct answer. Okay, so in this way you have to solve this type of problem. So if you see the next question, which of the followings is or are aromatic? So similarly, we will make one chart for these 4 molecules, and we will decide which of the following are or is aromatic. So let us see the chart. So this chart you can see for first molecule benzyne, I have given already my previous video fully for benzyne, and from that you can easily say that benzyne is aromatic in nature. So this is cyclic, this is conjugated, planar, and it obeys 4n plus 2 pi electron rules where n equal to 1, because the other pi bond, abnormal pi bond, does not contribute to the conjugation within the benzene ring. Okay, so that's why it's obeying Hückel rule 4n plus 2 where n equal to 1. So this is aromatic, we already know. And the next one is cyclic, and the conjugated molecule, this is fully planar, all are sp2 hybridized, and this is obeying 4n pi electron rules, because 4 pi electrons, that means n equal to 1, so 4n pi electron rules is getting obeyed by this molecule. So this is anti-aromatic in nature. And if you see the next one, so next molecule is cyclic, and this is conjugated, and this is planar, and this obeying 4n plus 2 pi electron rules where n equal to 1, because both the lone pairs on 2 nitrogen atoms they will not contribute to the conjugation because they are just outside of this molecule. So we will not count this both the alone pairs or nitrogen atom. That is why this compound is aromatic in nature. Okay, let us see the last one. So this one is cyclic, this is conjugated, this is planar, and this is obeying 4n plus 2 pi electron rules where n equal to 1. That means it has 6 pi electrons, 2 pi bonds, and if you see the negative charge for 2 electrons, so total we have 6 pi electrons. So this is also aromatic in nature. So here we got, see, compound P is aromatic, compound R is aromatic, and compound S is aromatic. So PRS, we have to find out which option is having PRS. So if you see, option A is having PRS, that means option A is the correct answer here. Okay, let us see next problem. Among the following compounds that is or are not aromatic. So this is, if you have to very careful with this term not aromatic, you have to find out. So 4 molecules are given, let us see. So similar chart we will prepare. If you see the first one, this is cyclic. So cyclic, and this is not conjugated because the double bonds are absent in the other side. Only 2 double bonds are there which are not conjugated in this cycle. Okay, so this is not planar because there are 2 sp3 carbon atoms. So this compound cannot be planar. This obeys 4n pi electron rules where n equal to 1 because 2 pi bonds are there. So this is non-aromatic in nature. If you see the next molecule, that is benzene, we all know that this is aromatic. So this is cyclic, conjugated, planar. This has 4n plus 2 pi electrons where n equal to 1. So this is aromatic, we all know. So no doubt about it. So if you see the next one, so this is not at all cyclic. So we will cross in the cyclic. So this is not cyclic, so we will not further study the other criteria 2, 3, 4. Okay, so this is not, this cannot be aromatic. This we will in the non-aromatic, that means this is not aromatic, simply not aromatic. Okay, so last one, you know, benzyne, just now I showed benzyne is aromatic molecule. So this is cyclic, conjugated, planar, and it obeys 4n plus 2 pi electron rules where n equal to 1. So this is aromatic. So we got our answer. So aromatic characters are compound Q and S, but in question they asked which are not aromatic. So not aromatic or non-aromatic are compound P and compound R. So we have to find the match with this option. So option P and R is option C. So option C is the correct answer here. So option C correct answer. Okay. So let us see next question. So GATE 2020 numerical problem. Among the following compounds, the total number of aromatic species is. So you have to find out how many compounds among all these 8 molecules, how many are aromatic in nature. So let us find out one by one about their 4 criteria, whether they are fulfilling 4 criteria or not. So one by one we will observe. So you first write down all these molecules. So first one, let us see. So this is cyclic, non-planar, because one sp3 carbon atom is there. So this is not conjugated and this is non-aromatic in nature. The second one, if you see, this compound is cyclic and planar, fully conjugated, and it obeys 4n plus 2 pi electron rule where n equal to 1. So this is aromatic. If you see the next one is cyclic, planar, fully conjugated, and it obeys 4n pi electrons rule where n equal to 1. So this is anti-aromatic in nature. So if you see the next one, this one also will be anti-aromatic, we have studied, because this is cyclic, planar, fully conjugated, and it obeys 4n pi electron rules where n equal to 1. So this is also anti-aromatic in nature. If you see the next one, here if you see, this is cyclic, planar, and fully conjugated, and it obeys 4n plus 2 pi electron rules where n equal to 0. So this is aromatic. And if you see the next molecule, so here also we have cyclic, planar, and fully conjugated structure, and this also obeys 4n plus 2 pi electron rules where n equal to 3. So we have total 14 electrons count here, and this is aromatic in nature. If you see the next one, this also aromatic because it has cyclic structure, planar, fully conjugated, and it obeys 4n plus 2 pi electron rules where n equal to 1, because lone pair on nitrogen atom also participate in the conjugation with the 2 pi bonds already there in the cycle. So this is aromatic. If you see the last molecule, so this has cyclic, planar, and fully conjugated structure, but it obeys 4n pi electron rules where n equal to 2. That means total 8 electrons this molecule is having. So this is anti-aromatic nature. So if you search only aromatic compounds, so you will get 1, 2, 3, 4. So there are total 4 molecules over here. Those are aromatic in nature. So in question we have to find out how many compounds are aromatic. So only 4 species are aromatic. So answer will be 4. Okay. So let us see the next question. So next question they asked, among the following compounds, the one that is non-aromatic. Here also non-aromatic you have to find out. So you go for one by one. So first one is cyclic, and this is not conjugated, not planar, because this molecule does not exist in the planar form. Again I am saying this molecule exist in the tub form or boat form, because that form is much more stable compared to the planar structure. So this obeying 4n pi electron rules where n equal to 2. So this compound is non-aromatic in nature. But if you see the other molecules, second one, that is benzyne. Benzyne is aromatic, we already know, and we have seen many times. So I will not show all these. So this is aromatic in nature. And if you see the next one, this one is anti-aromatic because it obeys 4n pi electron rules and other properties of the aromaticity. So this is anti-aromatic in nature. And if you see the last one, this is cyclic, this is conjugated and planar, and this obeys 4n plus 2 pi electron rules. So this is also aromatic in nature. So only first one is the non-aromatic species here. So in question they asked which is not aromatic. So option A will be the correct answer. Okay. So next question. The compound azulene. Azulene is, so 4 characteristics are given here. You have to search which of the following characteristic is matching with the molecule azulene. So structure of azulene in exam, it may or may not be given. So you have to remember structure of azulene, which is composed of one 7-member ring and one 5-member rings. Okay. So this is the azulene molecule. So 4 statements are given for the azulene molecule. So you have to find out which statement is correct. So let us see. So this is the structure of azulene. So if you see here, this is cyclic, planar, fully conjugated, and it has 5 pi bonds, that means 10 pi electrons. So 4n plus 2 pi electron rules is getting obeyed by this, where n equal to 2. So this is simply aromatic, and also we know that this compound is much more in the form of bipolar ion. Okay, so there are positive charge and negative end, so it exists in this type of dipole system. Okay, and this has, so if it has this type of structure which is much more stable compared to this cyclic structure, so this has higher dipole moment. So if you find the matches with these options given, so if you find this, see option A aromatic and it has dipole moment, because other options will not match this. The only aromatic, with aromatic only 2 options are there, A and B, but in option B there is no dipole moment, but azulene molecule is having permanent dipole moment because this exists as plus and minus, and this has dipole moment. So option A is the correct answer. So option A is the correct answer. So next question, if you see the compound that is not aromatic. So 4 compounds are given, you have to find out which is not aromatic. So if you make this chart one by one, so first one is cyclic, conjugated, planar, and it obeys 4n plus 2 pi electron rules where n equal to 1. So this is aromatic in nature. If you see the second one is cyclic, conjugated, planar, and it obeys 4n pi electron rules where n equal to 2, because 8 pi electrons are there total. So this is anti-aromatic in nature. And if you see the third one, so this molecule is exceptional. So if you see cyclooctatetraene, so this has 2 negative charges on it, and because of these 2 negative charges, this molecule is becoming conjugated. So So this conjugation is much more stabilized compared to the tub form or boat form. So here boat form will not exist. So this will remain as planar and conjugated with this type of structure only. And this has 4n plus 2 pi electron rules because total 10 electrons are there where n equal to 2 value. So it's matching with 4n plus 2 pi electrons, and this is aromatic in nature. So if you see the last one, this is also cyclic, this is also conjugated, planar, and it obeys 4n plus 2 pi electron rules where n equal to 1, because 2 pi bonds and 1 negative charge, total 6 electrons are there. If you put the value of n equal to 1, so 4n plus 2 pi electrons is matching with this. So this is also aromatic in nature. Okay, so three compounds are aromatic and one is anti-aromatic. So let us see which one of the following is not aromatic. So we got option B, that is option 2 is not aromatic because this is anti-aromatic in nature. Rest molecules are aromatic. Okay, so we got our answer. So option B is the correct answer here. If you see the next question, among the following, the number of aromatic compounds is. So you have to find out how many compounds are aromatic in nature. So 5 compounds are given. So you will go one by one. So if you see the first one, so this is cyclic, planar, fully conjugated. And if you see the resonating structure of these molecules, so this exists in this type of resonating structure, and because of this type of resonating structure, this is a fully conjugated and planar molecule. So this is obeying 4n plus 2 pi electron rules where n equal to 1, and this becomes aromatic. If you see the next molecule, this one is also cyclic, planar, and fully conjugated. And if you see the tautomeric form of this molecule, if you see, so here this exists like this, and if you see the tautomeric form, it has the 3 pi bonds, and which is claiming this molecule is also aromatic. So this is also 4n plus 2 pi electrons where n equal to 1. So this is also aromatic. If you see the next molecule, so this is cyclic, planar, fully conjugated, and this is obeying 4n pi electron rules where n equal to 1. So this is anti-aromatic in nature. If you see the next one, fourth molecule, so this has cyclic, planar, and conjugated structure. That means fully conjugated with this lone pair of electrons on nitrogen atom with methyl group, and the other lone pair on the nitrogen atom is not contributing to the this conjugation, so that will remain out of this ring. Okay, so this is obeying 4n plus 2 pi electron rules where n equal to 1. So this is also aromatic. If you see the last molecule, so this has cyclic, planar, and fully conjugated, and sulfur is having two lone pairs. One lone pair is contributing to this conjugation, and other lone pair remains as the outside. If you see my first lecture, there also I have already described with this orbital diagram. So one lone pair will be outside of the ring and one lone pair will be in the conjugation with the ring. So this obeying 4n plus 2 pi electron rules where n equal to 1. So this is also aromatic. So if you search for aromatic characters, so you will get total 4 aromatic species here. So out of 5, 4 aromatic species are there. So our answer will be 4. So see, option D is the correct answer here. Okay. If you see the next question, this is also numerical type question. So among the following, the number of molecules that are aromatic in nature. So 8 species are given. You have to find out how many aromatic molecules are here. So let us see one by one. So first one is, see, this is cyclic, planar, fully conjugated, and it has 4n pi electrons where n equal to 2. So this is anti-aromatic in nature, and if you see the second, you know this is non-aromatic because this has non-planar and non-conjugated structure, although it has 4n pi electrons where n equal to 2. So this is non-aromatic in nature. So next one is azulene, you have seen already. So this is cyclic, planar, fully conjugated, and it has 4n plus 2 pi electrons where n equal to 2. So this is aromatic. If you see the next one, this is also cyclic, planar, fully conjugated. All the carbons are sp2 hybridized and fully conjugated molecules, Here you have 4n pi electrons that were n equal to 3, so total 12 pi electrons are there. So this is anti-aromatic in nature. If you see the next one, so next molecule is cyclic planar fully conjugated, and it has 4n plus 2 pi electrons where n equal to 1. So this is aromatic in nature. And if you see the next one, so this is also cyclic planar fully conjugated, and here 4n plus 2 pi electrons where n equal to 3, because lone pair on nitrogen atom, this also involves in the conjugation, and it's making it having 4n plus 2 pi electrons where n equal to 3. So this is also aromatic. If you see the next one, so this is cyclic non-planar non-conjugated, because this, if you see this structure, this is non-conjugated. All the double bonds are not in conjugation because of they exist in the non-planar structures. It has 4n plus 2 pi electrons where n equal to 2, but this is not aromatic, this is non-aromatic in nature. If you see the next one, this is also cyclic non-planar. This molecule cannot exist in the plane because of strain, so this is not conjugated, and it is having 4n plus 2 pi electrons where n equal to 2, but this is non-aromatic in nature. So if you see here, how many? Only 1, 2, 3. So 3 molecules are aromatic in nature. So we got our answer 3. So there are 3 molecules that are aromatic in nature. Next question. Which of the following species is or are aromatic in nature? So A, B, C, D, 4 species are given. You have to find out. So this is MCQ type question. So multiple answer you can get from these options. Okay. So one by one we will see. So here if you see this is cyclic planar fully conjugated, and 4n plus 2 pi electrons where n equal to 2. Because all the lone pairs of nitrogen atom, 3 nitrogen atoms are having lone pair, but they will not come in conjugation with the ring double bonds. So here you have total 6 pi electrons, that is, it's fulfilling 4n plus 2 pi electrons where n equal to 2. So this is aromatic. And if you see the next one, this is cyclic planar fully conjugated, because the carbocation is making this molecule sp2 hybridized, and if you see the lone pairs on the oxygen atom, so it will be in the conjugation with the ring. So this is obeying also, this is fulfilling 4n plus 2 pi electron rules where n equal to 1. This is also aromatic. If you see the next molecule, this is cyclic planar fully conjugated. This is also 4n plus 2 pi electrons where n equal to 3. So this is also aromatic. If you see the next one, this molecule, this is cyclic planar fully conjugated, but this is obeying 4n pi electron rules where n equal to 2, because there are total 8 electrons, 2 pi bonds, 4 electrons, and 2 lone pairs from oxygen atom. So total 8 electrons are there. So this is anti-aromatic in nature. So if you search 1, 2, 3, so there are total 3 aromatic species among these molecule. Okay, so which 3? If you see the options A, B and C, so option B, A, B, C are the correct answer, because in this type of answer you have to find out that there can be multiple answer, because this is multiple select question. Okay, so there are 3 aromatic species A, B, C, and D is not aromatic. Okay, this is anti-aromatic. So we got our answer A, B, C. Next question, the species or compounds that are aromatic among followings are. So you have to find out PQRS, so 4 molecules are given, which compounds or which species are aromatic in nature. So we will go one by one. So this is cyclic, fully planar and fully conjugated. This obeys 4n plus 2 pi electron rules where n equal to 0, and this is aromatic. If you see the next one, so this is cyclic, this is planar, fully conjugated, and this obeys 4n plus 2 pi electron rules where n equal to 1. So this is aromatic in nature, because this exists in the conjugation with that oxygen negative. Okay, that's why this become aromatic in nature. If you see the next molecule, this is cyclic planar fully conjugated, 4n plus 2 pi electrons where n equal to 3, and this is aromatic. If you see the last one, so this is This is having one sp3 carbon atom, so this cannot be aromatic, this cannot be planar, this is non-planar and non-conjugated, and this has also 4n plus 2 pi electrons where n equal to 1, but this is not aromatic, this is non-aromatic in nature. So if you see 1, 2, so there are two molecules are aromatic. So which two? Let us see option D, P and S. You have seen that P and S, these two are aromatic in nature. Okay, so option D is the correct answer here. So next question. So if you see this question, this is also which of the following are aromatic. So you have to find out aromatic species. Let us see one by one. So first one, cyclic but not conjugated, it has sp3 carbon atom, so this cannot be planar, and this obeys 4n plus 2 pi electron rules where n equal to 1, but this is non-aromatic in nature because of non-planarity of this molecule. The next one is cyclic, conjugated, planar, and this obeys 4n plus 2 pi electron rules where n equal to 1, so this is aromatic in nature. And if you see the next molecule, this is cyclic, conjugated, planar, and this obeys 4n pi electron rules where n equal to 2. So this is anti-aromatic in nature. This is anti-aromatic compound. And if you see the last one, this is cyclic, planar, conjugated, and this obeys 4n plus 2 pi electron rules where n equal to 1. So this is also aromatic in nature. So we have option Q and S are aromatic, and option P is non-aromatic, option R is non-aromatic. So in question, which are aromatic? So option D is the correct answer. Option Q and S are aromatic in nature. Option Q and S. Okay. So next question, the correct statement about following species is. So two species 1 and 2 are given. You have to see which statement about these two molecules is correct. So let us see. So this molecule is cyclic, first molecule is cyclic, planar, and fully conjugated. If you see, this is fully conjugated because of these two negative ions. Okay, so 3 pi bonds, 6 pi electrons, and total 6 plus 4, because 2 form each negative charge, so total will be 10 electrons. So 4n plus 2 pi electron rules where n equal to 2. So this is aromatic in nature. If you see the second one, so see, this delocalization energy overcomes the angle strength factor of the molecules. See, if you see, you might have think that we know that for cyclooctatetraene, that molecule was in the top form or both form because of stability factor, but this delocalization factor of these two negative charges with these ring pi bonds makes them overcome the angle strength factor in the compared to that of cyclooctatetraene molecule. Okay, that's why this molecule is aromatic in nature, and both the negative charge will remain in the conjugation with these pi bonds. This is why this molecule is aromatic in nature. If you see the second molecule, so this is cyclic, planar, and fully conjugated. So 3 pi bonds, that means total 6 pi electrons, and 2 lone pair will be counted from the oxygen atom, because only 2, because other two lone pairs will not be counted because that is out of plane. So this other one will not count, only one lone pair we will count, and with this one lone pair, so there will be total 8 electron. So 8 electron means it is obeying 4n pi electron rules where n equal to 2. So this is anti-aromatic in nature. So if you go back to the statement given, so if you see, this option B is matching with our molecular statement. So if you see B, option B, 1 is aromatic and 2 is anti-aromatic in nature. So we have seen already this. So like this you have to answer this type of question. Okay. Next question, if you see the compound that is anti-aromatic, so you have to find out anti-aromatic in nature from these 4 compounds given. Okay. So one by one, if you see, first one is cyclic, conjugated, this is planar, and it is having 4n pi electrons because 2 pi bonds are there, so this is anti-aromatic in nature. We got our answer, but you have to test with other molecules also. So second one is cyclic, conjugated, planar, and it obeys 4n plus 2 pi electron rules where n equal to 1. So this is aromatic in nature. Okay. If you see the next one, this has one sp3 carbon atom, so this cannot be planar. This is cyclic, this cannot be planar, this cannot be conjugated, and this obeying 4n plus 2 pi electron rules, but this is non-aromatic in nature because of due to presence of one sp3 carbon atom on it. Okay. If you see the last one, so this is cyclic, this is conjugated, planar, and it's obeying 4n plus 2 pi electron rules where n equal to 0. And if you see the outside double bond, I have already said in my first video, the outside double bond, outside ring double bond we will not consider in the calculation of pi electrons. So there are only 2 pi electrons. That means if you put the n equal to 0, so it's matching with 4n plus 2 pi electrons. So this is aromatic in nature. Okay. So only non-aromatic compound is option C. So option C is the non-aromatic, but in question they asked which one is anti-aromatic. So anti-aromatic is option A. So option A is the correct answer. That means anti-aromatic species is option A. Okay. So next, among 1 to 3 aromatic compounds are. So 3 compounds are given. You have to find out aromatic compounds. Okay, let us see one by one. So first one is cyclic, conjugated, not conjugated. Apparently you can see this looks like conjugated, but this is not conjugated, because if you see this structure, these 2 hydrogen atom in the steric strain, so these hydrogen atoms cannot make this molecule planar. If it remains in the planar form, so there will be lot of steric strain because of these 2 hydrogen atom, and because of this is not all these pi bonds are not conjugated within this ring structure. Okay, and this molecule is not at all planar due to this steric strain. So this is not planar. This has 4n plus 2 pi electron rules, but this is not aromatic, this is non-aromatic in nature. Okay. If you see the next one, this is cyclic, conjugated, and planar, because this oxygen atom, epoxy oxygen atom, this is becoming outside of the ring, and all pi bonds are conjugated within this cyclic structure. Okay, and this is also follows 4n plus 2 pi electron rules, and there are you can see 5 pi bonds are there, so 10 electron system. So if you put the value of n equal to 2, so there will be total 10 pi electrons, and this is aromatic in nature. If you see the last one, so this is cyclic, this is conjugated, planar, and it also obeys 4n plus 2 pi electron rules with the 10 electron system, that means n equal to 2 value. So this is also aromatic in nature. Okay, so we got our answer. So option C is the correct answer. That means 2 and 3, compound 2 and 3 are the aromatic, and first one is not. So option C is the correct answer here. Okay. If you see this question, among the carbocations given below, so 4 statements are given about these 3 carbocations. You have to find out which statement is correct. Okay. So let us see what are the characteristics of these 3 carbocations. So if you see the first one, this is cyclic in nature, this is conjugated, and this is planar. Because if you see this structure, so this is a special molecule. In this special molecule, if you see, this exists in this form where this total ring is becoming like this, and one hydrogen atom, one sp3 carbon atom which is coming from the plane, and which will not come in the consideration of calculation of this number of pi electrons in this system. Okay, so this is totally coming from the planarity. Okay, and this type of aromaticity is known as homoaromaticity. So this is a special case. So these compounds becomes planar, and this also obeys 4n plus 2 pi electron rules, and this is homoaromatic in nature. So this is special characteristic compound. So this compound is termed as homoaromatic in nature. Okay. If you see the next one, so this is cyclic, conjugated, planar, and this obeys 4n pi electron system rules where n equal to 1, because 2 pi bonds are there, so there will be total 4 pi electrons. Okay, so this is anti-aromatic in nature. And if you see the last one, so this is cyclic, this is planar, this is conjugated, and these always 4n plus 2 pi electron rules where n equal to 0, and this molecule is aromatic in nature. So we got the statement about these 3 carbocations. So first carbocation is homoaromatic, second carbocation is anti-aromatic, and third one is aromatic in nature. So now go to the statement given and match your statement. So if you see, it's matching with option 1. That means A is homoaromatic, B is anti-aromatic, and C is aromatic in nature. So option 1 is the correct answer here. Let us see the next question. If you see this question, this is somewhat different from the traditional aromaticity question. Here 4 species are given and they have asked which of the following compound gives precipitate on warming with silver nitrate aqueous solution. Okay, so this also can be explained on the basis of aromaticity, and let us see how we can explain this answer. Okay, if you see the first molecule, so here you know the lone pairs are there with the bromine, which can involved directly with the benzene ring. Okay, so there is a possibility to form C double bond Br. So there is a partial double bond formation between carbon and bromine. So this bromine cannot be free from this molecule. So here if you apply aqueous silver nitrate, you will not get any PPT. So there will be no PPT with this molecule. Similarly, if you see the fourth molecule, so here also there will be a partial double bond formation between C and Br. Okay, similar in previous one. So here also there will be no PPT on treatment with aqueous silver nitrate. But if you see this molecule here, if this is CBr, and here there is no possibility of formation of CBr double bond, because it cannot go to the conjugation with the ring double bond. So here if carbocation forms, so there will be carbocation like this. And if you see this carbocation, so this carbocation is cyclic, planar, and this is having 4n pi electron rules. This is following 4n pi electron rules, and where n equal to 1. So because there are 2 pi bonds, that means 4 pi electrons, so it is anti-aromatic in nature. And because of anti-aromatic nature, so this carbocation is not stable, so there will be no formation of AgBr. That means here also no PPT will be there. But if you see this molecule here, if the carbocation forms which has cyclic structure, and this is planar and fully conjugated, and this is aromatic because it is following 4n plus 2 pi electron rules, because 6 pi electrons are there. So if put n value 1, so 4n plus 2, n value 1, it's matching with 6 pi electrons. So this is highly stable, and this is aromatic species. So this carbocation will form, and when this carbocation will form, the Br minus is forming AgBr precipitate with the aqueous silver nitrate solution. So among these 4 species, only this species will give the precipitate of silver bromide. Okay, so in this way you can explain this answer, and if you see, it's matching with option C. So option C will be the correct answer here. Okay, and last question of this session, if you see the following species is, so one species is given dication, and fourth statement is given whether it is homoaromatic or aromatic or anti-aromatic or non-aromatic. So this is also very simple. If you see this structure, so there are 2 cationic charge, okay, and 1 double bond. So this is completely cyclic, planar, and fully conjugated, because all carbons are sp2 hybridized. So this can be delocalized all over the cycle. Okay, and if you see the delocalization, so this is the delocalization structure. So here in this way, this double bond is getting delocalized within the cycle, and because of this is becoming aromatic, because it has 4n plus 2 pi electrons where n equal to 0. So this is also obeying Hückel's rule, and because of this aromaticity, so this will match with option B, because in option B this is aromatic, so option B will be the correct answer here. Okay, so in this way you can solve this. So I have shown here varieties of question and covered almost all type of compounds which comes in the exam. So if you go through this lecture, you will be able to perform in exam very quickly. If you still have some doubt, and also if you have some new question, you can put your queries in the comment section. I will give your answer, and if necessary I will make some short video with this new type of question, okay, related to the aromaticity. So thank you so much for watching this video, and I hope you can solve all the questions related to the aromaticity if you watch these 3 series of lectures. And please share this video, subscribe this channel if you have not done yet, okay, and thank you once again.